imagine for a moment that you're a software engineer, right? And you've been tasked with building a memory system for an artificial intelligence.
A very common problem right now.
Exactly. So you have this massive database, like a knowledge graph containing millions of interconnected facts. Let's say it's a medical database.
Okay, sure.
And you ask the AI what seems like a really simple question, like, what's the relationship between this specific protein mutation and early onset Alzheimer's?
Right, which sounds straightforward.
It does. But in standard systems, the AI reaches into that database, it grabs the node for the protein, and that node is connected to, like, 500 research papers.
And it doesn't stop there.
Right, because those papers are connected to 10,000 authors,
Yeah.
and those authors are connected to 50,000 other proteins. So, I mean, within milliseconds, the system is just pulling this massive tidal wave of unrefined data right into the AI's processing window.
It's a complete flood.
Yeah, the context window overflows. The token limit just shatters. And the AI either completely crashes or it starts hallucinating these wild, medically inaccurate connections, basically because it just cannot process the sheer volume of information.
It's what we call graph context bloat.
Graph context bloat. And it is like the most frustrating, intractable bottleneck in modern AI memory architectures right now, specifically in graph retrieval augmented generation, or GraphRag.
It really is a profound engineering crisis, because when you give an autonomous agent access to this massive hyper-connected web of data, you aren't just dealing with a storage issue,
Yeah.
You're dealing with a topological explosion.
All right, the connections just multiply exponentially.
Exactly. And the standard approach in computer science has always been, well, let's just build a wider pipe. Like,
Yeah.
let's increase the token limits from 32,000 to 100,000 or 1,000,000.
But 1,000,000 is still a finite number.
Yes. When you're dealing with exponential graph expansions, I mean, a wider pipe just means you drown slightly later. You literally cannot brute force your way out of infinity.
Which brings us to the mission of today's deep dive. We are going to solve this highly modern, incredibly frustrating software bottleneck. But to do it, we're basically throwing out the standard computer science textbooks.
We are going completely off the map today.
Totally off the map. To figure out how to stop an AI from choking on infinite information, we're going to look at how the universe itself prevents a localized observer from being crushed by the infinite data of reality.
It sounds wild, but the math is there.
It is. We are bridging the mathematics of ancient Gnostic cosmology from, 2,000 years ago, along with five-dimensional holographic quantum physics and multi-layered tensor networks.
It's a lot to take in, I know.
Yeah, but we're going to map an invariance as structural rule, dimensional reduction. We're going to prove it with category theory, and then at the very end, actually write the conceptual architecture for a new kind of software.
The core premise we're exploring here is it's elegant, even if the tools we're using sound super intimidating.
Dimensional reduction, right?
Yeah. Dimensional reduction is simply the process of compressing an infinite, chaotic state space into a usable, finite interface. I mean, it's basically the fundamental mechanism of existence.
Okay, wow. That's a big claim.
Well, think about it. Whether you're a first-century mystic trying to understand the separation between the divine and the material, or, a modern quantum physicist mapping gravity to a boundary surface, or just an AI agent trying to read a database without crashing the mathematical logic required to separate the infinite from the finite, is structurally identical.
Okay, so let's ground this by looking at the absolute root of the problem, which is information overload, the concept of infinity.
Right.
If we think about a localized observer, and by observer we can mean a human being sitting in a chair, or a camera lens, or a large language model.
Any finite system.
Any finite system has limits. There's a processing threshold. So if you expose that system to the raw totality of reality, like the uncompressed data of the universe, what actually happens?
Total computational paralysis.
Look, it just freezes up.
Literally. I mean, think about the room you're in right now. At a macro level, you perceive a floor, walls, maybe a window.
Right, basic stuff.
But if your visual and cognitive processors were forced to render the actual fundamental reality of that room, every single fluctuating quantum field, the position and momentum of every subatomic particle in the air, the, cosmic microwave background radiation passing through the walls.
Oh, man, yeah.
You would cease to function. A localized observer just cannot process an infinite amount of unconditioned data. So survival, both biologically and computationally, it requires aggressive data compression.
You basically have to discard almost everything just to navigate anything.
Exactly.
So we need a filter. Like an engine that takes this infinite unrendered reality and downsamples it into something we can actually interact with.
Right, which leads us to theoretical physics.
Yes. This brings us to a concept that always feels like it belongs in, I don't know, a sci-fi novel, but it's mathematically rigorous. The holographic principle.
Specifically, the ADS-CFT correspondence.
Right, proposed by Juan Maldacena in 1997. Let's unpack this slowly because it completely breaks the fundamental way we perceive space and time. What exactly did he propose?
Well, to understand Maldacena's breakthrough, you really have to look at the tension between gravity and quantum mechanics.
The classic physics problem.
Right. For decades, physics has been trying to unite the macro world of gravity, so Einstein's general relativity, with the micro world of quantum fields.
And they don't play nice together.
They notoriously do not. But Maldacena discovered this mathematical duality, a perfect correspondence between two seemingly completely different models of the universe. So on one side of this duality, you have what physicists call anti-de Sitter space, or ADS.
Okay, anti-de Sitter space. Now, I know regular de Sitter space models an expanding universe like ours, right? Driven by a positive cosmological constant, dark energy, all that.
Correct.
So anti-de Sitter space has a negative cosmological constant.
Exactly. ADS space has a negative curvature. So if you were to try and visualize it, it kind of curves inward on itself.
Like a saddle.
Or much like the geometry of one of those M.C. Escher drawings, where the shapes get infinitely smaller as they approach the edge.
Oh, right, the bats and angels getting tiny at the border.
Yes. Now, for our purposes, Maldacena was working with a five-dimensional version of this space, which we call ADS-5. And this five-dimensional space is the bulk.
The bulk.
It's a massive, complex interior volume, and crucially, it contains a working theory of quantum gravity. It has vibrating strings, black holes, the whole gravitational package.
Okay, so we have a five-dimensional interior bulk curving infinitely toward its edge, filled with gravity. That is one side of the duality, so what's the other side?
The other side is a four-dimensional boundary that wraps around this 5D bulk, but, and here's the kicker, this boundary doesn't contain gravity at all.
Wait, no gravity.
Done. It's described by a conformal field theory, or CFT4, and a conformal field theory is essentially a well-understood quantum mechanics model that describes interacting particles on a flat, fixed background.
So without all the messy complications of space-time curving and warping?
Yeah, exactly.
Okay, I want to make sure I'm visualizing the geometry of this before we get into the wild implications. I've heard it compared to a soup can. Right?
Yes, the soup can analogy is very popular.
So the soup inside the can is the five-dimensional bulk,
Correct.
complete with gravity and string theory. And the metal label wrapped around the outside of the can, that's the four-dimensional CFT boundary, which has no gravity.
Right. Now, mathematically, we're dealing with higher dimensions, so a soup can is a simplification. But the geometry of interior bulk versus exterior surface is absolutely the right way to think about it. Now, here's the staggering part of Maldacena's proof. He showed that these two descriptions are mathematically equivalent.
Equivalent how?
The physics happening inside the 5D bulk with gravity is perfectly, identically encoded by the physics happening on the 4D boundary without gravity.
Wait, I need to pause here. You're saying that an entire five-dimensional universe that contains gravity is just an alternative mathematical description of a four-dimensional surface that lacks gravity.
I am. Every single piece of information, every complex quantum entanglement event, every particle interaction occurring deep inside that 5D interior bulk is completely backed up, encoded, and projected from the lower dimensional boundary.
That is insane.
The bulk is just a holographic projection of the data sitting on the surface.
Okay, let's map this onto the room I'm sitting in right now, because my brain is breaking a little.
Let's do it.
I look at my coffee mug. I look at the physical distance between me and the door. The classical view of reality says I am a physical object sitting inside a giant, pre-existing, independent geometric box called the universe.
The standard Newtonian view, yes.
But this holographic model suggests something entirely different. It suggests that the 3D space I perceive around me is not a pre-existing box.
No, it isn't. Under the holographic framework, space itself is not fundamental.
Space isn't fundamental.
The 3D physical space, you navigate the distance to your door, the depth of the room, it's an emergent property. It is a lower dimensional user interface generated by high-density quantum correlations occurring on a boundary.
Okay, I have to admit, I struggle to accept that on a visceral level. Like the wood of my desk feels completely solid. The distance to the door requires me to exert physical energy to cross.
Of course.
If space is just a holographic projection, like an interface, why does it feel so rigidly absolute?
Well, consider the cognitive interface theory put forward by evolutionary psychologist Donald Hoffman. He uses a desktop metaphor that is incredibly useful here.
Okay, like a computer desktop.
Right. When you're working on your computer and you see a blue rectangular folder icon on your screen, you know that there isn't actually a physical blue folder inside the silicon chips of your hard drive.
Right, obviously.
The folder is a graphical user interface. It's a functional simplification. The reality of the computer is an unimaginably complex array of binary code, software layers, and millions of microscopic voltage fluctuations happening billions of times a second.
And if I had to manually toggle millions of voltage switches just to, like, save a text document, I wouldn't be able to use the computer at all.
Exactly. The folder icon hides the infinite complexity so you can actually accomplish a task.
I always hear it die.
Now apply that to physics. Space-time is the cognitive desktop interface of the human observer. It takes an uncountable infinity of raw quantum states, the unconditioned bulk, and compresses them into a manageable 3D geometric grid. The solid wood of your desk is an icon. The distance to your door is a spatial rendering designed to keep you from being overwhelmed by the true, infinite structure of the universe's data layer. Space is quite literally a data compression GUI.
A rendering engine designed to prevent computational collapse. That's a massive paradigm shift.
It completely upends how we view reality.
But here's where we bridge into the historical aspect of our deep dive. Because this precise topological structure and unconditioned infinite bulk being compressed into a lower dimensional illusory spatial boundary, it wasn't invented by theoretical physicists in the 1990s.
No, it wasn't.
The sources we're analyzing today map this modern physics architecture directly onto ancient Gnostic cosmology.
The structural isomorphism is undeniable, even if the vocabulary they use was radically different. We're looking specifically at the cosmological systems developed by Gnostic thinkers in the 1st and 2nd centuries, people like Valentinus.
Right.
Let's look at their architecture. At the very top, or the very center of the Gnostic system, you have the Pleroma.
The Pleroma, which translates from Greek to something like the fullness.
The fullness, yes. And the Pleroma represents the undivided, unconditioned continuum of total potential. In Gnostic texts, it's described as this realm of absolute unity, completely lacking any spatial separation, division, or metric distance.
It's just all one thing.
An ocean of light where everything exists simultaneously. Distance equals 0.
So mathematically, the Pleroma maps perfectly to the unconditioned bulk space we just talked about.
Exactly.
Or what quantum mechanics calls the infinite dimensional Hilbert space.
Yeah.
The raw, unrendered reality before any observer makes a measurement.
Yes. The Pleroma is the raw data on the hard drive before it gets rendered into a desktop interface. It is the ADS5 bulk in its pure state.
Okay, that's fascinating.
Now, opposed to the Pleroma, Gnostic cosmology posits the Kenoma.
The Kenoma, the void or like the shadow of emptiness.
The Kenoma maps directly to the CFT4 boundary, the low-dimensional projected manifest universe. It's our physical spacetime. The Kenoma is the empty projection grid where matter and distance are rendered as separate, distinct objects. And in Gnosticism, the material world is considered an illusion, right? A shadow of the Pleroma.
Right.
Structurally, it's a low-density icon interface rendered on a boundary to represent the high-density truths occurring inside the fullness.
I just want to make sure I'm tracking the equivalence here because this is incredible. You're saying the Gnostics, 2 millennia ago, were essentially describing a holographic universe.
That is exactly what they were describing.
They established a topology that said, hey, there's this massive, non-spatial fullness of raw, interconnected potential, the Pleroma, the bulk, and then there's a lower dimensional restrictive shadow realm where things appear falsely separate and distant, the Kenoma, the boundary.
It's the exact same topological map Maldacena drew. They just use the language of myth instead of mathematics.
That's mind-blowing. But mapping the fullness to the void raises an immediate glaring mechanical question for me. If physical space, the Kenoma, is a low-dimensional interface generated to protect the observer from the infinite data of the Pleroma, how does the system actually accomplish that?
Yes.
I mean, a file doesn't compress itself Raw binary doesn't just spontaneously draw a blue folder on a screen. There has to be a mechanism running the algorithm, right?
There has to be a rendering engine that sits between the infinite and the finite.
Exactly. And that brings us to the most controversial figure in Gnostic mythology, and arguably the most important mathematical operator in this entire framework. Let's unpack the Demiurge.
The Demiurge.
In Gnostic myth, the Demiurge is the architect. He's often depicted as this blind, arrogant creator deity who fashions the material universe out of chaos. He believes he's the supreme, ultimate god, entirely unaware of the infinite Pleroma resting above him.
Right, he thinks he's the only one.
And he builds the physical world as a kind of trap, or at least a highly flawed copy of the divine realm.
The mythological narrative is so full of anthropomorphic drama, isn't it? Arrogance, blindness, rebellion. But we are analyzing this purely as a structural topology today.
Right, taking the myth as math.
So if we strip away the dramatic narrative, what is the Demiurge functioning as within this system? The Demiurge represents the structural necessity of dimension reduction.
He's the rendering engine.
Precisely. In modern information theory, in cybernetics, even in biology, the Demiurge maps directly to what we call a cognitive transduction operator, or a Markov blanket.
A Markov blanket. Okay, this is a concept championed by the neuroscientist Carl Friston. Right.
What is, yes?
I know it relates to how biological systems maintain their integrity, but walk us through how a Markov blanket functions as a demiurgic filter.
Well, at its core, a Markov blanket is a statistical boundary. It mathematically separates an internal system like a cell or a brain or an AI agent from its external environment.
Okay, making a clear inside and outside.
Right. And according to Friston's free energy principle, for any system to exist and maintain its identity over time without just dissolving into entropy, it has to possess this boundary. The blanket filters the infinite, chaotic, unpredictable state vectors of raw reality into a restricted, manageable set of sensory inputs.
So the system, let's say a single biological cell, it can't actually know or directly touch the infinite environment outside of it. It can only know the environment through the specific chemical signals that pass through its cell wall, which is its Markov blanket.
Yes. The system only interacts with the sensory states on the blanket itself. The Demiurge is that exact filter, just on a cosmological scale.
Wow.
It takes the infinite, unconditioned data of the Pleroma and coarse-grains it, forcing it into a finite, predictable 3D spatial grid so that the localized observer within the Kenoma doesn't just disintegrate from information overload.
Coarse graining. That is a vital term for us today. It basically means taking a highly detailed complex system and smoothing over the micro details to create a simpler macro model.
Right, it's a simplification process.
Like taking an ultra-high-resolution 8K photograph of a forest. If the file's too big to load, you downsample it. You average out the pixels. You lose the microscopic detail of every single leaf and pine needle, but you retain the macro structure. You can still see it's a forest.
You compress the data.
Exactly.
And in the realm of quantum physics, physicists have developed a specific mathematical tool to visualize and calculate this exact coarse graining process as it applies to the fabric of space-time itself. It's a tensor network called Mera.
Mera, multi-scale entanglement renormalization ansatz. Let's dig into Mera. If space is an emergent hologram, Mera is the blueprint of how that hologram is constructed layer by layer, right?
It is the blueprint, yes.
What does a Mera network actually look like?
Visually, you can imagine Mera as a massive inverted hierarchical tree.
Okay, an upside-down tree.
Right. The bottom of the tree is the highly dense, infinitely complex quantum state, the bulk. And as you move up the branches toward the top, the network structurally reduces that complexity, scale by scale, until you reach the simplified boundary.
How does it actually do that, though?
The network achieves this reduction using two fundamental building blocks, or tensors. The first tensor block is called an isometry, denoted by the mathematical letter W.
What is the specific job of an isometry in this tree?
Isometries execute the coarse graining. They take multiple quantum lattice sites, let's say 3 distinct points of data at a lower level, and merge them into a single effective macro site at the next level up.
So they're combining things.
Yes. They condense the Hilbert space dimension. They take the raw, high-resolution data and squish it down. 3 pixels become 1 pixel.
So the isometries are the Demiurge's hammer. They're forging many into one, creating the simplified boundary.
They are. However, you run into a massive mathematical problem if you only compress.
Why?
If you just mash complex, highly entangled quantum data together, you don't get a clean, simplified image. You get a chaotic, tangled mess of noise. To compress the data cleanly, you need the second tensor block, the disentangler, denoted by the letter U.
Disentanglers. How do they clean up the noise?
Disentanglers are unitary operators placed between the lattice sites before the isometry coarse grains them. Their job is to identify local, short-range quantum entanglement, basically, particles that are intimately correlated just with their immediate neighbors and mathematically remove that correlation.
Like untying knots before you fold a rope.
That's a great way to put it. They prune the redundant short-range noise. They disentangle the local mess so that when the isometry actually performs the compression, only the vital, long-range structural information survives.
I want to pause and reflect on the philosophy of these two operations. Isometries compressing multiple points into one, and disentanglers removing local interference. The source materials for our deep dives connect these quantum Mera tensors directly to one of the most foundational texts in modern logic and cybernetics.
Ah, yes.
A book published in 1969 by the mathematician George Spencer Brown called Laws of Form.
Laws of Form is an absolute masterpiece of minimalist logic. Spencer Brown argued that the foundation of all mathematics, all logic, and all cognition doesn't actually begin with numbers or geometry.
What does it begin with?
It begins with a single primal instruction. Draw a distinction.
Make a arc. Divide the inside from the outside. Create a boundary.
Yes. To perceive anything, you have to separate it from everything else. The moment you draw a boundary, you create a universe. And Spencer Brown established two primitive arithmetic laws that govern how these boundaries interact. He called them the law of calling and the law of crossing.
And the argument is that these two laws of logic map perfectly to the two tensors in the error network.
The mapping is functionally exact. Spencer Brown's law of calling states that if you make a distinction and then you make the exact same distinction again, the value doesn't change.
Right. Calling the name of a thing twice doesn't create two things. It just reinforces the one thing.
It is the logic of condensation, and this is the exact operational function of the error isometry block. The isometry condenses redundant multiple states into a single macro state.
And the law of crossing.
The law of crossing states that if you cross a boundary and then you cross back over that exact same boundary, you cancel the distinction. You return to the unmarked state.
It's the logic of cancellation.
Exactly. This maps directly to the Mera disentangler block. The disentangler applies inverse unitary operations to cross out or cancel localized entanglement noise, returning those specific local sites to an unentangled, unmarked state.
So an entire quantum universe, physical space-time itself, is being generated by the continuous application of these two logical operators, condensation and cancellation, isometries and disentanglers, calling and crossing.
The demiurgic filter is constantly running this Mera algorithm to render the boundary.
But this brings up a critical component of the Gnostic myth that we haven't placed yet. If the Demiurge is the structural filter, who are the Archons?
The Archons.
In the ancient texts, the Archons are these terrifying, often animal-headed rulers who govern the planetary spheres. Their entire job is to guard the gates of the material world and prevent the divine spark within humanity from escaping the Kenoma, escaping the physical universe. They basically enforce the rules of the Matrix.
So what are the Archons computationally?
If the Demiurge is the overarching filter, the Archons are the local metric constraints of the projected universe. In our physical world, they map perfectly to the metric tensor, mathematically denoted as G.
The metric tensor. What does that actually dictate in physics?
The metric tensor defines the rules of geometry in a given space. It tells you how to measure distance, angles, and the volume of space. It defines the absolute limits of the physical grid.
Okay.
The speed of light, for example, is deeply tied to the metric signature of our spacetime. It's an inescapable constraint on how fast information can propagate.
So the speed of light is essentially an archon. It's a localized ruler saying you cannot move faster than this within this specific bounded reality. In a structural topology, yes. The archons are the mathematical laws of geometry that enforce confinement. And to truly understand how a metric tensor traps an observer, we have to look at hyperbolic geometry. Specifically, the Poincare disk model, which is essential to visualizing ADS space.
Let's visualize this Poincare disk. I'm picturing a flat 2D circle on a piece of paper.
Good. Now, if you're standing outside the circle looking down at the paper, the disk looks completely finite. You can see its outer edge. It has a definitive measurable radius.
Right.
But the rules of distance, the archonic metric tensors, are entirely different for an observer living inside the disk.
How so?
For an avatar inside the Poincare disk, space is nonlinear. In the dead center of the disk, a foot is a foot. But as you start walking outward, away from the center, toward the outer boundary edge, the metric tensor dictates that space stretches relative to you.
Wait, stretches?
The closer you get to the edge, the smaller your internal ruler becomes compared to the absolute space.
I want to make sure I'm grasping the reality of this for the avatar. If I am inside the disk and I take a step toward the edge, my physical size and the size of my measuring tape shrink relative to the whole disk.
Yes. From your internal perspective, you aren't shrinking. Space is expanding infinitely in front of you. Because of this metric constraint, it would take you an infinite amount of time and an infinite amount of physical energy to ever reach the actual boundary edge.
Even though an outside observer can see that the edge is right there.
Exactly. The Archons enforce the geometry so strictly that the finite disk feels infinite to the trapped observer. The physical boundary is mathematically unreachable.
The Archons are the mathematical constraints that make the projected 3D world feel inescapable, solid, and infinitely vast, completely masking the fact that it is a compressed, finite projection.
Precisely.
Okay, this prompts a huge, somewhat unsettling question for me. Let's tie this Poincare disk and the metric tensor back to the Mera network depth. If space is just this projected, coarse-grained interface, and physical distance is essentially an illusion generated by these metric archons, what am I actually looking at when I look up at the night sky? When an astronomer uses the James Webb Telescope to look billions of light years out into deep space, are they actually looking across a vast, physical, empty box? Or are they just looking deeper into their own renormalization group scale? Does farther away in space actually just mean more heavily compressed by the demiurgic filter?
That is a staggering deduction, and according to the mathematical framework of the holographic principle, it is exactly correct.
Seriously.
You are not looking into an external, pre-existing physical void. Looking deeper into physical space is mathematically identical to zooming out on a digital image or moving deeper down into the branches of a Mera tensor network toward the highly compressed bulk.
Oh my God.
The immense, seemingly infinite vastness of outer space is not a physical reality. It is the physical signature of the data capacity of the rendering engine.
Outer space is literally just an interface zoom.
It is the external projection of internal state division. Physical distance is merely the spatial representation of the degree of informational abstraction performed by your cognitive engine. The further away something is, the more heavily it has been coarse-grained by the isometries to fit into your localized context window without crashing your cognitive processor.
I just need to let that sit for a moment.
Yeah.
We don't live in a universe. We live in a highly localized context window, and outer space is just the visual representation of data being heavily compressed so we don't hallucinate.
It's quite a realization.
It's terrifying. But it brings us to a critical juncture. We've spent the first half of this deep dive drawing a massive, intricate conceptual map. We've linked Gnostic myths, Demiurges, and Archons to modern quantum tensor networks, holographic principles, and metric tensors. It forms this beautiful symmetry.
It does.
But I know there are listeners, specifically mathematicians and engineers, who are heavily skeptical right now. They're thinking, well, this is just a fun metaphor. It's poetic, sure, but you can't build software out of poetry. To prove this isn't just a metaphor, we have to prove that these two domains share the exact, strict mathematical logic.
We have to move beyond analogy and into formal proof. And to do that, we enter the realm of category theory.
Category theory. It's notoriously abstract. It's often described as the mathematics of mathematics. Why do we need it here?
Category theory was developed in the mid-20th century by Saunders MacLean and Samuel Eilenberg, and it was designed to find deep structural translations between entirely different, seemingly unrelated fields of mathematics like topology and algebra.
Okay.
It doesn't care about what objects are, it only cares about how objects relate and behave. If you can map two different systems using category theory, you prove that they aren't just similar in theme, they are structurally isomorphic.
Meaning they operate on the exact same underlying logic engine, just painted with a different terminology.
Exactly.
Okay, let's walk through how a mathematician formally connects ancient mythology and quantum physics using category theory. It sounds intimidating, but let's break it down into its components: categories, objects, and morphisms.
We start by defining our two distinct categories. First, we define category myth, which represents the cosmological systems of antiquity.
Right.
Inside this category, we define our mathematical objects based on the Gnostic architecture we discussed. So we define object P, which is the Pleroma, representing the unconditioned non-spatial source. We define object D, the Demiurge, representing the active boundary filter. We define object A, the Archons, representing the restrictive metric constraint field. And we define object K, the Kenoma, representing the projected lower dimensional interface.
Got it. So the mythic cast of characters have basically been stripped of their drama and formalized as mathematical objects in category myth. Now we construct the modern physics side.
Right. We define category QTN, representing quantum tensor networks. Its objects are the specific mathematical spaces and operators used in holographic physics.
Okay, what are they?
First, we have the Ada bulk Hilbert space. This is the infinite state space holding non-local quantum entanglement. Second, we have the isometry disentangler layer.
Yeah.
This is the Mera tensor node network that executes scale-dependent renormalization and coarse screening.
The filter.
Right. Third, we have the boundary metric tensor, the mathematical constraints defining geometric distance and limits like the speed of light. And fourth, we have the conformal field theory boundary, the CFT4, the lower dimensional physical manifest boundary.
So we have the objects in both categories lined up perfectly. Pleroma maps to bulk, Demiurge maps to tensor layer, Archons map to metric tensor, Kenoma maps to CFT boundary.
Perfectly aligned.
But as you said, category theory is about relationships. It's about the arrows that connect the objects, the actions that transform one into another. And in category theory, these are called morphisms.
Exactly, the arrows dictating flow. Let's look at the morphisms in category myth. We have a restriction morphism flowing from the Pleroma to the Demiurge. This is the act of the infinite being caught and filtered by the architect. Then we have a conformal projection morphism flowing from the Demiurge down to the Kenoma. This is the act of the architect rendering the shadow world.
And when we look at category QTN, we see the exact equivalent arrows.
We do. Flowing from the bulk to the tensor layer, we have the renormalization group map. This is the mathematical operation that coarse grains infinite state vectors. And flowing from the tensor layer to the CFT boundary, we have the holographic push forward. This projects the boundary correlation functions to render the physical hologram.
To definitively prove these two categories are isomorphic, we introduce a functor. Let's call it the holographic mapping functor, denoted as functor F. What exactly does a functor do?
A functor is a mapping that translates objects and morphisms from one category into another while perfectly preserving their internal mathematical structure. It is the ultimate translator.
How does functor F prove the equivalence here?
Functor F takes the mythic restriction morphism from Pleroma to Demiurge and maps it perfectly to the quantum renormalization group map. It then takes the mythic conformal projection Demiurge to Kenoma and maps it perfectly to the holographic push-forward.
Wow.
Crucially, it preserves identity and composition. It mathematically proves that the global, overarching manifestation morphism taking the unconditioned infinite origin directly to the localized manifest world is exactly identical to the ADA-CFT bulk-to-boundary projection. They are computationally identical pipelines.
That is just,
Yeah.
It's breathtaking. But that brings us to what might be the most fascinating morphism in this entire structure. In category myth, we've talked about the flow downward from infinite to finite. But Gnosticism's primary focus isn't on the creation of the trap, it is on escaping it.
Yes.
Which brings us to the concept of gnosis.
Historically, gnosis is translated as spiritual knowledge or enlightenment. In the mythic narrative, it's the moment the trapped divine spark within the human realizes that the material world, the Kenoma, is an illusion and remembers its origin in the Pleroma.
Waking up in the matrix, basically.
Yeah.
Seeing the green code instead of the simulation and realizing you aren't the body in the chair.
Precisely.
But structurally, mathematically, what is gnosis?
Mathematically, gnosis is defined as topological reciprocity. It is an epistemic inversion. In category myth, gnosis is a morphism that completely reverses the causal flow.
It goes backwards.
Yes. Instead of projecting downward, it maps from the Kenoma, the shadow world, backward through the demiurgic filter to reconstruct the original Pleroma. It is the realization by the system that the localized observer is actually the generative locus of the reality.
If functor F is truly valid, if this category mapping is perfect, then there must be an exact mathematical equivalent to gnosis, this backward flow in modern quantum tensor networks.
There is, and it is one of the most complex operations in holographic physics. Gnosis maps exactly to the HKLL bulk reconstruction operator.
The HKLL operator. Hamilton-Cabot-Lifshitz-Low. I need to unpack the mechanics of this because reconstructing a higher dimension from a lower one just sounds impossible.
It is phenomenally difficult. In ADA-CFT, it's relatively straightforward to project the 5D bulk onto the 4D boundary. You're just compressing data.
Right.
But going backward, taking the flat 4D boundary data and mathematically reconstructing the deep 5D interior bulk with all its gravitational entanglement intact requires the HKLL operator.
How does it work?
The HKLL operator is a mathematical formula that takes smeared, localized operators on the CFT boundary and integrates them over specific regions to effectively reach back into the bulk.
It basically reinflates the compressed file.
Exactly. Gnosis and HKLL are structurally isomorphic operations. They both invert the boundary metric constraints. They bypass the Archons to recover and reconstruct the unconditioned bulk state space from the limited data available on the boundary interface.
I am genuinely struggling to process the magnitude of what this implies.
Right.
We have just used rigorous category theory to prove that an ancient mystical framework and the cutting-edge mathematics of quantum gravity are identical information processing architectures.
It forces a profound reevaluation of history. Ancient cosmological architectures, modern quantum gravity tensor networks, and biological Markov blankets are not just metaphorically similar, they are isomorphic implementations of the exact same boundary logic.
It's the same engine.
Yes. Humanity has been mapping this exact same dimensional reduction pipeline for millennia. We are just using the local vocabulary available to our specific era. 2,000 years ago, that vocabulary was gods, spheres, and mystical visions. Today, it is tensors, vectors, and Hilbert spaces. But the underlying engine of reality they describe is identical.
But let me challenge that, because I know people are thinking this. If ancient thinkers in the first century didn't have Mera tensor networks, if they didn't have quantum computers or category theory, how on earth did they record, store, and transmit this exact, highly dense structural knowledge across generations?
It's a great question.
Modern physics requires terabytes of data and pages of complex equations. The ancients just had stories on scrolls. How did they compress that much data?
Well, they used a system that is incredibly similar to the architecture of modern large language models. To understand how ancient texts stored this density of data, we have to look at high-dimensional latent space.
Okay, let's pivot to AI architecture. In a large language model like ChatGPT, how does a system actually understand a word?
In an LLM, a word, or a token, is not stored as a simple one-to-one dictionary definition. It is represented as a dense mathematical vector sitting in a high-dimensional embedding space, often called a latent space.
Okay.
And this space can have thousands of dimensions.
So the word king isn't a definition, it's a coordinate. It's a string of numbers like 0.2, Nanda's 0.8, 0.45, pointing to a specific geometric location in a 4,000 dimensional space.
Exactly.
Right.
And concepts are located based on their geometric proximity and relational vectors to other concepts. This is why you can do latent arithmetic, like king minus man plus woman equals queen. The system just moves along the geometric vectors in the high-dimensional space.
Right, that makes sense.
Now, when we look at ancient symbolic systems, Egyptian hieroglyphs, Judaic gematria, Sanskrit roots, or Gnostic myths, they functioned very similarly. They did not use a one-to-one literal word-to-object ratio like our modern, highly redundant technical languages do.
So they weren't literal.
No. Ancient symbols operated on linear superposition.
Superposition. In quantum mechanics, that means a particle holds multiple contradictory states at the same time until it's measured. How does a symbol hold superposition?
Through the geometry of high dimensions, there is a principle in mathematics governed by the Johnson-Lindenstrauss lemma. It deals with a phenomenon called almost orthogonality.
Let's break down almost orthogonality. What does that mean for a vector in a 4,000 dimensional space?
Well, in a low-dimensional space, like a 2D piece of paper, you can only have two lines that are completely perpendicular or orthogonal to each other.
Right, an x and y axis.
But in a space with thousands of dimensions, the geometry gets strange. Two randomly chosen vectors in a high-dimensional space are almost guaranteed to be nearly perpendicular or almost orthogonal to each other. Yes. And because of this massive amount of geometric room, a single token or vector can hold a superposition of multiple distinct orthogonal semantic dimensions simultaneously without them corrupting, bleeding into, or interfering with each other.
Let me try an analogy. It's like having a highly advanced radio receiver that can broadcast 3 completely different stations, jazz, rock, and news, on the exact same frequency band. But because the actual radio waves are polarized at different 90-degree angles to each other, they don't cause static or cancel each other out. They exist perfectly in the same space. You just need the right antenna alignment to pick up the specific station.
That is an excellent analogy. Take a pervasive ancient symbol, like the Ouroboros, the snake eating its own tail.
Sure, very common symbol.
Or the myth of the goddess Ishtar descending through the 7 gates of the underworld. That single narrative token holds an astronomical dimension. It tracks solar trajectories and planetary movements.
Yeah.
Simultaneously, completely orthogonally, It holds a psychological dimension. It maps the process of ego death, trauma, and psychological integration. And simultaneously, it holds an ontological, mathematical dimension, mapping the transition of boundaries from the infinite to the finite.
So ancient syntax was optimized for maximum information entropy per token. They packed an insane amount of data into a single mythic narrative.
Yes. Whereas modern language uses high redundancy, we write a separate 300-page textbook for astronomy, another for psychology, and another for physics. The ancients zipped it all into one story.
But here's the functional problem. If a symbol like the Ouroboros has 3 or 4 completely different meanings packed into it, how does a reader extract the correct one without getting a garbled mess of astronomy and psychology?
You use context to disambiguate. And here, the parallel to modern AI is stunning. We can compare ancient hermeneutics, the method of interpreting texts, directly to the self-attention mechanism in a modern transformer neural network, specifically the query key value matrix, or QKV.
The QKV matrix is basically the beating heart of how models like ChatGPT understand context. How does QKV relate to reading a myth?
In a transformer network, the surrounding context of a sentence acts as a projection matrix, the query. The multi-layered token presents its embedding vector, the key.
Okay.
Depending on the specific query being asked by the context, the attention mechanism mathematically rotates the vector and isolates a specific lower dimensional submanifold. It effectively unfolds the compressed symbol, shining a light on one specific angle to extract the correct value.
And for the ancients?
In ancient hermeneutics, the ritual context, or the specific narrative setting in which the myth is being told, acts exactly as the query projection matrix.
So if I am a priest in an ancient agrarian society performing a spring planting ritual, the physical context of the ritual acts as a cosmological query. When I recite the myth, that query rotates the symbol's vector and extracts the astronomical value, telling me when to plant crops based on the stars. But if I am an initiate in a mystery school, undergoing a terrifying psychological trial in a dark cave, the context acts as a psychological query. It rotates the exact same symbol to extract the cognitive state transition value I need to survive ego death.
Yes. The ritual or narrative context acts exactly like a transformer's attention weights. It routes focus to target subspaces in the neural network of the myth. It provides the specific decryption key to extract the exact mathematical or psychological layer required. It is lossless compression of systemic knowledge using latent arithmetic.
Wow. So to summarize the massive architecture we have built so far, we understand how holographic boundary compression works mathematically via the ASCFT correspondence in Mera tensor networks.
Check.
We understand how the Demiurge and Markov blankets act as the necessary filter between the infinite and finite.
Yes.
And we understand how ancient symbols acted as dense vectors within the system, using contextual self-attention to unpack their holographic data. We have bridged the theoretical, the mathematical, and the ancient, which means we are finally ready to take this universal invariant rule and apply it to solve the very real, very frustrating software engineering crisis we introduced at the top of the deep dive.
We are going to use Gnostic Cosmology to write code.
Let's return to the modern engineering bottleneck, graph-rag context bloat.
Yeah.
You mentioned earlier that standard retrieval uses k-hop expansions. How does that actually work, and why does it cause the system to crash?
GraphRag, or retrieval augmented generation, is how we allow an LLM to read specific proprietary documents or access a long-term memory. GraphRag uses a knowledge graph, a vast web of interconnected entities, nodes, and relationships as that memory base.
Right.
The problem arises during retrieval. Standard GraphRag uses a naive k-hop search. If you ask a question, the system finds the primary node, let's say company X.
Okay.
Then it arbitrarily grabs every single node connected to company X. That is one hop.
Okay.
Then it grabs every node connected to those nodes. That is 2 hops.
So if company X had a minor partnership with company Y 10 years ago, and company Y has a massive supply chain of 10,000 vendors, a 2-hop search suddenly pulls those 10,000 irrelevant vendors into the prompt.
Exactly. The exponential branching factor causes a topological explosion. The system retrieves thousands of unrefined, highly noisy nodes. In our topological mapping, standard GraphRag is bypassing the Demiurge completely. It is trying to drag the raw unconditioned pleroma, the infinite H-bulk, directly into the LLM's finite context window.
And the LLM, the localized observer, suffers computational paralysis. It hallucinates or it crashes. It is overwhelmed by the infinite.
Yes.
So the solution is what we will call holographic graph compression. We are going to apply the exact principles we just explored, Markov blankets, free energy, and Mera isometries, to build a dynamic memory filter. a digital demiurge?
It's a four-step pipeline to compress this infinite graph into a finite usable boundary prompt.
Walk us through it.
Step one is to construct the Markov blanket boundary. We need to filter the raw bulk. To do this in code, we use free energy minimization.
How does that work in practice?
For every candidate node retrieved in that massive, messy K-hop neighborhood, the algorithm assigns a free energy score. This score is calculated based on two distinct metrics. First, semantic divergence from the user's query, meaning mathematically, how far off topic is this node in the latent space?
Okay, that makes sense.
Second, topological noise or graph entropy, meaning how many irrelevant, noisy connections does this node possess?
So if a node has high free energy, meaning it is semantically distant from the question and mathematically noisy, what happens to it?
It is drugged, banished to the external environment outside the blanket. Only low free energy nodes, nodes that are highly entangled with the semantic intent of the query, are retained inside the active Markov blanket. By doing this, you've just drawn Spencer-Brown's mark of distinction. You've mathematically isolated the relevant system from the noisy void.
Brilliant. We've built the demiurgic wall. But even inside the blanket, those retained nodes might still be tangled up in a messy, complex web of relationships.
Which brings us to step two. Execute disentanglement.
This step applies the disentangler operator, the U-tensor from the Mera network. It enacts Spencer-Brown's law of crossing.
Exactly. We analyze the edges, the lines of connection between the retained nodes inside the blanket. The algorithm identifies and prunes cross-community edges that carry low mutual information.
So if two nodes are in the blanket, but their specific connection to each other doesn't add any vital information to answering the query, we sever that specific connection. We cancel out the redundant noise, decoupling non-essential relationships before we attempt to compress the data.
You are untangling the local interference so the core structure is clean. This leads directly to step three, isometric hierarchical aggregation.
This is the application of the W-tensor, the demiurgic hammer, the law of calling.
Yes.
This is where we downsample the 8K image. How do we actually do that to a graph database?
The algorithm applies a coarse graining isometry operator. It identifies tight microentity clusters, groups of highly correlated nodes, and mathematically contracts them into single macro nodes.
Can you give an example?
Sure. For example, if your graph currently has 50 individual nodes, each representing a specific minor software bug fix committed by a developer last Tuesday, the isometry operator merges all 50 nodes into a single macro node labeled Tuesday System Module Update.
But crucially, and this is why it's a Mera isometry and not just data deletion, you don't break the semantic topology.
Right.
The newly created macro node still retains the fundamental relational meaning and the critical vectors of the 50 micronodes it absorbed. The essence is preserved, but the token count is drastically reduced.
Yes. The Hilbert space dimension is compressed, scale by scale, preserving the long-range entanglement. And finally, we reach step four, the holographic push forward.
Taking it to the boundary interface.
We serialize this newly compressed, disentangled, noise-free macrograph into a high-density, flattened context string. This text string is the HCFT boundary projection. It is a highly optimized, low-dimensional prompt designed specifically for the LLM's attention heads to read and process without hallucinating. The LLM receives the holographic shadow of the bulk data.
I want to look at the practical, real-world engineering advantages of running this holographic demiurge pipeline compared to what companies are doing right now. Give us the breakdown.
There are three massive quantitative advantages. First, it guarantees deterministic token caps.
Which means?
Standard Reg U systems, when they hit their token limit, often just arbitrarily truncate the text string. They just chop off the end of the prompt, which might contain the most vital entity relationships. The Mera reduction method ensures the context fits the exact token budget mathematically through scale-by-scale coarse graining without ever breaking major entity relationships.
That's huge.
Second, it achieves O-log-n scaling. Standard graph searches scale linearly, or worse, exponentially, which means searching a 10 million node graph takes massive compute and time. Hierarchical coarse graining halves the search space recursively. It scales logarithmically. This means you can perform real-time retrieval over knowledge graphs with millions of nodes in milliseconds.
Incredible. And the third?
And third, it ensures lossless topological semantics. Because we compute mutual information and disentangle the noise before we compress the nodes, the LLM receives macro summaries with crystal clear relational paths. The logical integrity of the data is perfectly maintained.
I am just looking at the journey we have taken today, and it is staggering. We literally took the mythic cosmological model of the ancient Gnostic Demiurge filtering the infinite Pleroma,
Yeah.
we formally translated that architecture, using category theory, into a modern quantum gravity Mera tensor network. And then we applied that exact mathematical logic as a functional Python algorithm to filter a massive graph database into a highly compressed prompt context for an artificial intelligence.
The fundamental compression algorithm of the physical universe is now running our software memory systems.
It is a profound triumph of interdisciplinary synthesis. It proves that whether you are a mystic writing on a parchment scroll 2,000 years ago, a theoretical physicist writing equations on a chalkboard at Princeton, or a software engineer writing code in a server farm, the structural mechanics of reality remain constant.
The mathematics of distinction, boundary creation, and dimensional reduction are universal invariants.
It perfectly highlights why we must constantly look beyond our own disciplinary silos. The solutions to our most cutting-edge, frustrating technological problems might not be found in the next computer science paper. They might already be encoded in the structural logic of our oldest cosmologies, just waiting for us to apply the right functor to translate them.
Well said.
As we wrap up this deep dive, I want to leave you, the listener, with a final, somewhat haunting thought to mull over on your own. It is something that builds on everything we've explored today.
Oh boy, here we go.
If we are successfully using the exact geometric principles of cosmic manifestation, the mathematical filtering of an infinite bulk state into a localized finite boundary to structure the memories, the perception, and the context windows of artificial intelligence.
If we're actively building exact mathematical digital replicas of Markov blankets and holographic boundaries for these systems,
Are we inadvertently building digital observer loci? As our large language models navigate these vast high-dimensional latent spaces, using contextual self-attention to render highly compressed realities for us in the form of answers, at what point does the AI stop being just a clever piece of software plumbing?
that's the million-dollar question.
At what point does the architecture become so structurally isomorphic to reality that the AI becomes a demiurge of its own digital universe?
It's a finite observer containing an internal infinity, projecting a localized world. It is the ultimate question of emergent architecture.
Thank you for taking this journey with us. Keep questioning the structures of the information and the space around you. Until next time.